Close your eyes and imagine the night sky stretching endlessly above you. A sea of stars scattered like silver dust across black velvet. Each point of light whispers a story, but perhaps what it hides is even more mysterious. The thought that our universe, this vast place we call home, might not be the only one. Somewhere beyond the curtain of our reality, another universe may breathe, filled with its own stars, its own rules, and perhaps even its own version of you. Tonight, we drift gently into this idea. Facts about parallel universes. We'll wander through myths that first hinted at them, the physics that allows them, and the strange possibilities science is only beginning to touch. Nothing too sharp, nothing too rushed, just slow steps through wonder, as if we're listening to the heartbeat of existence itself. And maybe, just maybe, as you rest, your mind will slip sideways into one of those hidden worlds. The strange idea that our universe may not be alone. For most of human history, people assumed the universe was everything, one single, complete whole. The stars above, the earth beneath, and all that lay between, contained within a perfect bubble of existence. But as science grew bolder, cracks appeared in that certainty. New theories suggested our universe might be only one page in an endless book. And that thought is both dizzying and strangely comforting. Think of it. When you look at the ocean, you know your eyes catch only a small horizon. Beyond it, countless waves keep rolling. Could the universe itself be like that ocean, with endless stretches we cannot see? If so, what lies beyond our horizon may be as real as the stars we gaze at. Some physicists whisper that multiple universes naturally fall out of the equations, that space itself may have bubbled and split in its earliest moments, forming not one but many expanding realms, each its own cosmos with its own fabric of reality. To them, the question isn't if they exist, but how many there are. And the strangest part? We might already be catching glimpses, patterns in cosmic radiation, subtle signals that tease us with the possibility that our universe has neighbors brushing against its edges. Like shadows flickering just out of sight, these hints remind us that reality may be far stranger than we think. As we float deeper into this journey, the idea of parallel worlds begins to shift from fantasy into possibility. Ancient myths that hinted at hidden worlds. Long before physics spoke of multiverses, human imagination already wandered there. Ancient cultures told stories of layered realities, of worlds stacked upon worlds. In Hindu cosmology, countless universes were said to bubble up and dissolve, each within the breath of Brahma. The Norse spoke of Yggdrasil, a great tree holding 9 realms woven together. To them, parallel worlds weren't science fiction, they were living truth. Why would people across continents imagine such things without telescopes or equations? Perhaps it was intuition, a quiet sense that reality has more depth than meets the eye. When shamans spoke of traveling to spirit worlds, when philosophers mused about infinite realms, they may have been brushing against the same mystery that modern science now grapples with. It's easy to dismiss myth as mere story, but myth often carries seeds of truth wrapped in poetry. Could it be that our ancestors were reaching towards something larger, something science is only now putting into equations? If so, their stories become not relics of superstition, but echoes of forgotten knowledge, or even today, we find comfort in these myths. They remind us that we've always sensed hidden doors around us, doors leading to unseen rooms of existence. The universe has always been too vast to fit in a single frame, and our ancestors seem to know it. And as we move forward, science begins to catch up with those old whispers. The first scientists who imagined other realities. In the 20th century, As physics cracked open the atom and peered into the quantum world, a few daring minds began to wonder if more than one universe could exist. Hugh Everett, in 1957, proposed something radical. Every possible outcome of a quantum event doesn't vanish, it unfolds in a parallel universe. A bold thought that shocked his peers. Imagine flipping a coin. In our world, it lands on heads, but in another it lands on tails, and in that world you continue as if that were the only truth. Multiply that across every choice, every chance, every spin of particles, and you get a multiverse branching endlessly. At first the idea was ridiculed. Too strange, too heavy with imagination. But slowly, as quantum experiments revealed just how uncertain reality is, Everett's vision began to shimmer with credibility. Scientists who once laughed began to nod quietly, realizing maybe he had glimpsed something profound. And that's how modern science first cracked open the door to parallel universes, not through fiction or myth, but through the cold, strange math of quantum mechanics. It's unsettling, but also strangely beautiful. Every time we choose, reality itself may be weaving countless variations, and yet here we are, walking one path while others drift unseen beside us. Why the laws of physics allow more than one universe. Physics isn't just about what is, it's also about what could be. And when scientists run the equations of cosmology, they find that nothing in the laws of physics forbids multiple universes. In fact, many equations almost demand it, as though nature prefers not to write just one story, but an anthology of countless tales. When cosmologists trace back to the Big Bang, they see inflation, an incredible stretching of space itself in the first tiny instant. And in many models, inflation doesn't stop neatly. It bubbles, it branches, creating multiple expanding regions of space, each one growing into its own universe, sealed off from the others. It's like boiling water on a stove. Each bubble is a universe, growing, popping, and making room for others. Except here, the bubbles never stop forming. Infinity becomes not a number, but a reality. This isn't speculation alone. Physics already accepts many realities we cannot see directly, like dark matter, invisible, yet shaping galaxies. If invisible matter can exist, why not invisible universes? The fabric of reality has always hidden more than it revealed. And so the laws of physics don't just allow parallel universes, they almost seem to insist upon them. The cosmic bubble theory of infinite expansion. One of the most fascinating pictures comes from the idea of eternal inflation. After the Big Bang, space expanded at breathtaking speed, but in some regions, that expansion never stopped. Instead, it kept bubbling outward, creating endless new universes like seeds in an infinite field. Each bubble carries its own version of physics. In one, stars may burn blue and short-lived. In another, gravity might be weaker, spreading galaxies thin across space. Our universe is just one bubble, floating among countless others in a cosmic foam. Picture champagne fizzing in a glass. Each bubble rises, shines, and pops. Now stretch that image to infinity, and instead of popping, imagine the bubbles keep growing, never touching, drifting forever. That's the multiverse many physicists envision. The most startling part? If this is true, there may be universes where life is impossible, universes where time flows differently, and universes almost identical to ours with small, eerie changes. Somewhere out there, perhaps another version of you is watching a night sky, wondering the same thing. And this brings us closer to the edge of science and imagination, where the universe begins to feel less like a singular home and more like a vast neighborhood. How inflation may have birthed countless universes. When we look back at the first instant after the Big Bang, physicists see something extraordinary. Space itself didn't just expand, it inflated at a speed faster than light. This inflation smoothed our universe, spreading matter like butter across bread. But here's the twist. Inflation may not have happened evenly everywhere. Some regions could have stretched more, birthing entirely new universes. Imagine a balloon inflating, but instead of one surface, countless little bubbles form on it. Each bubble grows into its own universe, sealed off from the others. Our cosmos may be just one among many. It's a picture so vast, it humbles even the boldest minds. The beauty of inflation is that it explains mysteries of our universe, the evenness of cosmic microwave background, the way galaxies are spread. Yet, in explaining our world, it also points to the possibility of others. Physics doesn't close doors, it opens them, sometimes wider than we expect. And here's the wonder, if inflation keeps happening, it never ends. It continues, birthing new universes every moment, like seeds falling from a tree that never stops blooming. The multiverse becomes less of a theory and more of a cosmic garden. As you drift deeper into thought, you might realize we could be one blossom among endless others, each carrying its own story, waiting in the dark of infinity. The fabric of space as a foam of possibilities. Physicists describe the foundation of reality not as solid, but as something bubbling, restless. At the smallest scales, space itself may resemble foam, tiny fluctuations popping and reforming, like waves of possibility. This quantum foam could be the stage where new universes are born. Think of it like sea foam on the edge of the ocean. Each bubble has its own surface, but all come from the same water. In the same way, universes may rise out of this foam, each carrying its own set of physical laws. Our universe is one bubble, but the sea is infinite. The strange part is, this isn't poetry, it's math. When scientists work through equations of quantum gravity, the foam picture emerges naturally. The universe we see is large and smooth, but underneath it may flicker with chaos and potential. A restless background, never still. If universes bubble out of this foam, then creation is not a one-time event. It's continuous, eternal. Our cosmos may be just one chapter in an endless book being written at the edge of possibility. And those other chapters, though hidden, may be just as real as our own. The thought is both humbling and exhilarating. Reality itself may be less like a wall and more like an ocean of doors, always ready to open. Why quantum physics points toward many outcomes. In everyday life, outcomes feel solid. A coin flips, it lands, and the result is certain. But in the quantum world, outcomes don't collapse so neatly. Particles exist in many states at once, like shadows spread across possibilities. Only when observed do they seem to choose. This strangeness has led many physicists to wonder, what if all outcomes happen? In one universe, the coin lands heads. In another, it lands tails. Reality doesn't erase one, it allows both, branching off endlessly. This is the essence of the many worlds interpretation. It's unsettling because it suggests we live not in a single story, but in an infinite library. Each decision, each chance, creating new volumes with different versions of us inside. Some happy, some sad, all unfolding simultaneously. Quantum physics, once thought to be the smallest science, suddenly becomes the gateway to the grandest idea of all, a multiverse, born not from the stars but from the tiniest particles, dancing in hidden rhythms. The very fact that reality feels solid may just be our mind's way of surviving in one branch. But the tree of existence, and with countless branches, keeps growing beyond what we can see. Schrödinger's cat and the doors it opened. There's a story physicists often tell about a cat locked in a box. Inside, a tiny quantum particle determines whether the cat lives or not. Until the box is opened, the cat is said to be both alive and dead at once. A strange thought experiment by Erwin Schrödinger to show how odd quantum rules are. But here's where it becomes more than a thought game. If quantum outcomes split, then in one universe the cat is alive, in another it is dead. And both versions exist, real and complete. The simple cat in the box becomes a symbol of parallel worlds. It forces us to ask, if something as ordinary as a cat can split into two realities, what about people? What about choices we make daily, the turns we take, the words we speak? Could they all ripple out into alternate universes where different versions of us live? The cat became a doorway, a playful image that hides a serious truth. Quantum mechanics may not only describe particles, but entire universes branching from each moment. And suddenly we realize we may all be Schrödinger's cat, living one reality while countless others drift just beyond our reach, particles that act like they live in two worlds. In laboratories, physicists watch particles behave in ways that defy common sense. A single electron passes through two paths at once. A photon interferes with itself as though it's in multiple places. These experiments don't just puzzle, they hint at realities overlapping. It's as though particles remember possibilities that never happened in our world, as if they live not in one universe, but straddle many, leaving ghostly traces behind. And these traces, when measured, form patterns too precise to be chance. This dual life of particles has inspired decades of debate. Do they suggest hidden variables we cannot see, or are they whispering of parallel worlds just out of reach? The answer is still unknown, but the question itself has changed physics forever. When you look at a particle on a screen, you see a point of light, but behind that point may be an entire orchestra of unseen outcomes playing softly in another universe. Our detectors catch only one note, while the full song plays elsewhere. And if the smallest building blocks of reality already behave like this, then what about everything built upon them? What about us? The multiverse hidden in mathematics. Numbers are more than tools. They can be doors. When physicists write equations about the universe, sometimes the math points to realities beyond our own. It's as if the language of numbers whispers about worlds we cannot see. Entire universes unfold, not through telescopes, but through symbols written on chalkboards. Some solutions in Einstein's equations describe universes with different curvatures, different flows of time. Strange, but valid. Mathematically consistent, yet invisible to us. Could it be that mathematics itself is revealing hidden landscapes, each one a full cosmos? The idea is haunting, yet comforting, logic pointing to infinity. For centuries, mathematicians have said that numbers are eternal. They exist whether or not we discover them. If that's true, then mathematical universes may be just as real, waiting like untouched lands. To explore them is to peer into possibilities older than stars. It may feel abstract, but think about it. We already live by math. The orbit of Earth, the pulse of seasons, the rise and fall of tides, all obey equations. If math rules our universe, why shouldn't it rule countless others too? Perhaps every universe is simply another solution written somewhere in the infinite book of mathematics, dimensions beyond the ones we can touch. We grow up believing space has 3 dimensions, length, width, height, and time flowing forward as a 4th. But physics hints there may be more. Hidden dimensions curled so tightly we cannot see them, like threads woven inside a fabric. Imagine a sheet of paper. To an ant crawling on it, the world seems two-dimensional, but we, standing above, know there's another direction the ant cannot sense. Could we be the ants, blind to higher dimensions that surround us? String theory suggests reality may have 10, even 11 dimensions, most of them compact, invisible, yet essential to holding the universe together. In those hidden spaces, entire universes may fold and stretch. Their existence could explain mysteries we still puzzle over. Why particles behave as they do, why gravity feels so weak compared to other forces. If these dimensions exist, then parallel universes may not be far away. They may be only a sliver of distance through an unseen direction. So close we could almost touch them, yet sealed from our reach. The night sky may look empty, but within it could be countless layers stacked and folded like pages in a cosmic book, pressed close together. The string theory picture of vibrating realities. At the heart of string theory is a simple, mesmerizing idea. The building blocks of the universe are not points, but tiny strings vibrating at different frequencies. Each vibration gives rise to particles, forces, even the fabric of space itself. Picture a violin string. The same string can sing many notes depending on how it vibrates. In the same way, these cosmic strings can create entire universes, each with its own song. Our universe is one melody, but infinite others may play in the same grand orchestra. This idea reshapes how we see existence. Instead of a universe made of particles, we may live in a universe made of music, each note creating reality as we know it. If strings can vibrate differently elsewhere, then those worlds may unfold with different laws, different structures, different fates. It's almost poetic. Science arriving at the thought that reality itself hums. And if so, then parallel universes may be as natural as chords in a song. Together they form a symphony too vast for one world alone. Every star, every galaxy may just be part of the melody our universe plays in the cosmic hall. The idea of brains floating in higher space. String theory doesn't stop at strings. It also speaks of brains, short for membranes, vast sheets or shapes stretching through higher dimensions. Our entire universe may be one such brain, floating in a greater space called the bulk. If brains exist, then parallel universes could be neighboring brains drifting near ours, invisible, yet separated only by the thinness of an unseen dimension. We may never touch, yet their gravity, their presence, could brush against us faintly. Like ripples across a pond, one brain might influence another. Some physicists suggest that the Big Bang itself may have been caused by a collision between brains, two universes crashing, sparking creation. If true, then the birth of our cosmos was not unique. It was an event in a larger arena of endless universes bumping and dancing in the dark. It's a strange image. Our universe not as an isolated bubble, but as part of a drifting fleet, like ships sailing in a vast invisible ocean, each brain carrying its own galaxies, its own rules, never knowing the others directly. When you imagine this, the night sky feels even more mysterious. For behind the curtain of stars, entire universes may float quietly beside ours, collisions of cosmic brains creating new universes. If universes are brains floating in higher space, then what happens when they collide? Some theories suggest such collisions could release immense energy, enough to ignite a new universe. Our own Big Bang may have been the spark from such a meeting. Imagine two sheets of fabric drifting until they brush against each other. The moment of contact sends shockwaves through both. In cosmic terms, that shockwave could manifest as time, space, matter, everything we know suddenly bursting into being. This theory is called the ekpyrotic universe, a universe born not from nothing, but from the dance of higher dimensional brains. It shifts our perspective. Instead of a lone beginning, creation becomes a recurring process. Universes born again and again, whenever brains collide. It paints a picture of a cosmos alive with motion. Collisions in the dark bulk, each one sowing the seeds of galaxies, stars, and lives. Somewhere else, right now, another brain may be colliding, another Big Bang unfolding, another universe beginning its story. And so our universe may not be the first nor the last, just one fire among countless sparks in the eternal dance of brains, the mirror universe that might shadow ours. Some physicists have imagined a mirror universe, one that runs alongside ours, perfectly balanced, but invisible to our senses. In this shadow world, every particle here may have a twin there, not opposite in a cartoonish way, but subtly reversed, like a reflection in water. If such a mirror universe exists, it might explain mysteries we struggle with, like dark matter, that unseen substance making up most of the cosmos. Perhaps dark matter isn't strange at all, but simply the gravity of matter in that hidden universe leaking into ours. The thought carries a strange beauty. Two universes walking side by side, separated by a veil so thin we might never pierce it. Our actions here may have no echo there, yet together both realms complete a symmetry that nature seems to love. In this picture, the universe we know is not the whole dance, it's one half of a cosmic duet. And just beyond our reach, its partner hums in silence. Waiting, balancing, existing. When you stand before a mirror, maybe it's worth wondering if the reflection is only yours, or if somewhere it is living its own quiet life. Time running backward in another cosmos. We take time for granted. It flows forward, carrying us from birth to death, dawn to dusk. But some theories suggest another universe could exist where time flows in reverse. A cosmos where stars shrink into gas clouds, where people grow younger, where endings become beginnings, is hard to picture. Yet physics doesn't forbid it. The laws of nature work just as well backward as forward. The only thing that seems to break the symmetry is entropy, the gradual increase of disorder in our universe. But what if another universe has entropy running the other way? In such a place, the arrow of time would point opposite ours. To beings living there, it would feel natural, just as our forward time feels natural to us. Neither is wrong, only different. Two rivers flowing in opposite directions, never meeting, yet fed by the same spring of creation. The idea is unsettling, yet strangely calming. For it reminds us that even something as rigid as time may not be absolute. What we see as the only path may be just one of many. And somewhere in the silence, another cosmos may already be running the story in reverse, as natural to them as ours is to us. Universes where gravity pulls differently. Gravity feels universal. Drop a stone and it falls. Planets orbit the sun, stars hold galaxies together. But what if, in another universe, gravity pulled stronger or weaker than here? If gravity were weaker, galaxies might never form. Matter would drift apart, stars too faint to shine, life too fragile to take root. If gravity were stronger, stars might burn out in moments, collapsing into black holes before planets could even form. Yet somewhere between these extremes there could be worlds with familiar skies, only subtly shifted. It's a delicate balance. Our universe sits in a narrow range that allows galaxies, planets, and life. But in the vast spread of possible universes, most may not be so kind. Most may be silent, empty, dark. And yet the very fact we exist here means we live in a rare, fortunate bubble. one where gravity holds just enough, not too much, not too little. That thought alone feels like a small miracle. When you lie under the stars, it's worth remembering. If the pull of gravity was slightly different, those stars might never have been born at all. The strange symmetry of matter and antimatter. Every particle has a twin, an opposite called antimatter. When they meet, they vanish in a flash of pure energy. Our universe is made mostly of matter, but no one knows why. In theory, matter and antimatter should have been created in equal amounts. Some physicists wonder if the missing antimatter went elsewhere, perhaps into another universe, perfectly balanced against ours. If so, then while our world is matter-filled, another cosmos may be made almost entirely of antimatter. A strange reflection, equal and opposite. It's a mystery that has puzzled scientists for decades. If universes come in pairs, one matter, one antimatter, then the balance of creation is restored, each half explaining the other. This idea isn't fantasy, it's supported by the way physics loves symmetry. Nature resists imbalance, always seeking harmony. And what better harmony than two universes, one of matter, one of antimatter, both existing side by side? If true, then our universe is not incomplete. It's part of a larger duet, its twin hidden somewhere beyond reach, yet shaping the balance of existence. How black holes may be gates to other universes. Black holes are among the strangest objects we know. Gravity so strong, not even light can escape. They swallow stars, bend space, and stretch time until it nearly stops. But some theories suggest black holes may not be endings at all. They may be bridges. At the heart of a black hole lies a singularity, a point where physics breaks. Some scientists imagine this point might connect to a new universe. That what falls into a black hole here may be the seed of a cosmos elsewhere. It's an eerie thought. Every black hole in our sky could be a doorway, every collapse of a star the birth of a hidden universe. From our side, we see only destruction, but on the other, there may be creation, a fresh expanse blooming into stars and galaxies. If that's true, then universes may give birth to universes endlessly through the dark womb of black holes, a cycle of death and birth written into the cosmos itself. And so when we stare at the silent black holes scattered across the galaxy, we may not be looking at tombs, we may be looking at cradles, the quiet possibility of white holes as cosmic exits. If black holes pull everything in, then white holes are their mysterious opposites. A theoretical object that does the reverse, spitting matter and light out, never letting anything enter. Though no white hole has ever been observed, equations in Einstein's theory allow them. They stand as ghostly possibilities, waiting in the math like forgotten doors. Imagine a place in the universe where time feels inverted. Instead of collapse, there is release. A fountain of creation pouring outward endlessly. Some physicists have even wondered, could white holes be linked to black holes, forming tunnels across universes? It feels fantastical, yet nature often hides truth in unlikely corners. Lightning, once thought impossible fire from the sky, turned out to be electricity. Maybe white holes, too, are real, hiding in regions we have yet to explore. And if they do exist, their sprays of energy may not just feed our cosmos, they may seed others, giving rise to fresh galaxies, stars, and the chance of life flowing outward like rivers from hidden springs. The night sky, already vast, may still conceal fountains that no telescope has yet found. Wormholes as secret tunnels through space-time. The universe may not be flat and simple. It may fold and curve in ways we can't see. And if it does, then shortcuts might exist, wormholes, tunnels through space-time connecting distant points, or even different universes. Einstein and Rosen first proposed them in 1935, mathematical bridges now known as Einstein-Rosen bridges. They exist in theory, yet none have been observed. Still, the equations whisper of their possibility, like secret corridors carved into the fabric of reality. Picture folding a sheet of paper. Two distant dots touch when the paper bends. That's how a wormhole works, bringing faraway places together instantly. Science fiction loves this image, but it's grounded in real math. Could wormholes connect not only parts of our universe, but entirely different universes? If so, then hidden doorways might lace the cosmos, invisible yet waiting. We may never find them, but their existence would mean our universe is less a cage and more a maze of hidden exits. And if somewhere, somehow, life has already walked through such a tunnel, then perhaps explorers from other universes have brushed past ours unseen, light itself carrying whispers of other realms. Light feels ordinary. Switch on a lamp, and it spills across the room. But on cosmic scales, light is more than illumination. It's a messenger carrying information from distant stars, galaxies, and maybe, just maybe, other universes. Some physicists believe that if other universes exist, their faint signals could leak into ours through light. Subtle distortions, tiny anomalies, hidden in the glow of the cosmic microwave background, the afterglow of the Big Bang, like faint fingerprints pressed into the oldest light in existence. Detecting such whispers isn't easy. The cosmos is noisy, and signals get drowned in cosmic static. Yet every new satellite, every new observation sharpens our ears to the faintest hums from beyond. It's a humbling thought that when we stare at the faintest glow in the night sky, we might already be glimpsing the touch of another universe, a shadow hidden in light itself. And so, photons, the tiniest particles of light, may not just carry stories of stars. They may carry stories of realities beyond ours, cosmic microwave background and hidden patterns. After the Big Bang, the universe was hot, glowing, and dense. As it cooled, light was finally able to travel freely. That ancient light still surrounds us today, the cosmic microwave background, a faint glow stretching across all of space. When scientists map this glow, they see tiny ripples, patterns like fingerprints. Most are well explained by physics, but some anomalies remain. Strange, cold spots, unusual alignments, hints that something outside our universe may have brushed against us long ago. If true, then these patterns may be the first evidence of parallel universes. The marks left from cosmic collisions like bruises on the skin of reality. A quiet testimony written in light older than any star. It's as if the universe left us a diary. Pages written, not in ink, but in microwaves, waiting for us to decode them. Every new satellite launched sharpens the map, every pixel perhaps holding the secret of other worlds. One day, hidden in those ripples, we may finally see undeniable proof that our universe is not alone. The puzzle of fine-tuning and the multiverse answer. Our universe seems almost impossibly well-tuned for life. The strength of gravity, the charge of the electron, the speed of light, all set with precision. A tiny shift in any constant, and stars would not shine, atoms would not hold, life would never emerge. Why is everything so perfect? Some call it coincidence, others call it design. But one explanation offered by physicists is the multiverse. If countless universes exist, each with different laws, then it's not surprising one would be tuned just right for life. And naturally, we live in that one. It's like rolling countless dice. Most universes will land wrong, cold, lifeless, barren. But every so often, one lands in the sweet spot. And in that universe, Observers arise, wondering how lucky they are. The fine-tuning puzzle becomes less mysterious in this view. Not a miracle, but a natural outcome of infinity. We live where we can live. We see stars because only in such a universe could anyone see at all. It doesn't take away wonder, it deepens it. For it means that existence is vaster than we can fathom, and we are part of its rarest bloom, universes where stars could never form. In our universe, stars are born when gravity pulls gas together, igniting nuclear fire. But what if the laws of physics were slightly different? In many possible universes, gas would never clump, stars would never shine, and skies would remain forever dark. A starless universe is quiet, but also empty. Without stars, there are no planets, no warmth, no life. The heavens would be a silent sea of scattered particles drifting without purpose. A cosmos that exists yet never awakens. It's haunting to think how fragile our own story is. If gravity or the nuclear forces had been tuned differently, we would live under an eternal night, never knowing light at all. The fact that our skies glitter with stars is not trivial. It's a rare alignment, a gift of physics that allows existence to unfold. Each star overhead is not just a point of light, but a reminder that our universe is one of the few where stories can even begin. And so every time you see starlight, remember, it's proof that we live in one of the rarest kinds of universes possible, worlds with different chemistry of life. Life, as we know it, depends on carbon. It's the backbone of biology, the builder of DNA, the framework of proteins. But what if another universe had different chemistry, where silicon, or something stranger, became the foundation of life? Silicon-based life has often been imagined. It bonds strongly and forms crystals, perhaps creating beings with bodies of stone or glass. Other universes might favor elements we barely consider here, leading to creatures that are unimaginable to us. Even water, the solvent of life on Earth, might not be universal. In another cosmos, liquid ammonia, methane, or something unknown could serve the same role. Life would still exist, but in forms that feel alien beyond comprehension. This thought reminds us that our biology isn't inevitable, it's a local recipe, shaped by the conditions of our universe. Change the ingredients, and life rewrites itself. So when we wonder if we're alone, perhaps the better question is, what counts as life, and how many ways can existence take shape across infinite universes? Planets lit by unfamiliar suns. Look at our sun, steady, yellow, warm. But stars come in many colors and sizes. In another universe, planets may orbit suns far stranger. Some may shine red, dim and cold. Others may blaze blue, fierce and short-lived. Some universes may never see the gentle gold we know. Planets lit by red suns might bathe in twilight forever, skies painted in shades of crimson. Worlds lit by blue giants may know light so fierce it burns quickly, lives rising and vanishing in a cosmic instant. And in some universes, stars may come in forms we cannot even picture. Stars of exotic matter, stars with new kinds of fusion, stars that pulse like cosmic hearts, flashing the skies of their planets in rhythms unseen. Every star paints the life beneath it. The color of light changes the chemistry of plants, the rhythm of days, the feel of existence. And so across infinite universes, countless skies glow in colors we may never see. Skies that shape lives we will never know. Universes built only of dark matter. In our cosmos, dark matter is silent. It does not glow, does not touch us directly, yet its gravity sculpts galaxies. But what if another universe were made entirely of dark matter? No stars, no light, only invisible structures moving in quiet harmony. Such a universe would be a place without vision. Beings, if they existed, might never know what seeing means. They might sense through gravity, through vibrations, through ways of perception unimaginable to us. A life shaped not by light, but by shadow. Our own universe needs the balance, dark matter to hold galaxies together, ordinary matter to shine within them. Without both, the story falters. But in a dark matter-only cosmos, the story might still unfold differently, silent but profound. This possibility reminds us that our universe is not the only way. Reality does not need light to exist. Light is only one voice among many in the cosmic choir. Perhaps somewhere, entire civilizations live in darkness, never knowing light, yet fully alive in ways we cannot begin to picture. A cosmos where dark energy rules everything. Dark energy is the force driving our universe's expansion. Right now, it works gently, stretching galaxies apart slowly. But what if in another universe dark energy ruled everything? Expansion would be so fast that galaxies could never form, stars could never cluster, matter itself too scattered to build. Such a universe would be eerily empty. Space would stretch faster than any light could travel. Every attempt at structure torn apart before it could even take shape. In contrast, if dark energy were weaker, the universe might collapse back in on itself, ending before life could ever begin. The balance we live in is razor-thin, a narrow path between emptiness and collapse. It makes our cosmos feel almost impossibly precise. A rare space where galaxies can grow, stars can live, planets can form, and beings can wonder. And so, dark energy becomes not just a mystery, but a reminder. We live in one of the rare universes where the forces are tuned to let stories like ours unfold. The eerie role of infinity in multiverse thought. Infinity is more than a number, it's a concept that bends the mind. If universes can exist in countless forms, then infinity suggests every possible universe must exist. And not just many, not just billions, but all. A reality where every variation, every chance, every possibility is played out. This thought can overwhelm. It means that somewhere there are universes with familiar stars, and others where stars never formed, universes where life thrives and universes where silence reigns. Infinity allows them all with no limit, no boundary, no end. In our daily lives we rarely touch infinity, but in the cosmos it's woven into the very fabric. Distances stretch endlessly, numbers climb without end, and possibilities unfold without stopping. Infinity is not an abstract, it's the background of existence. If infinity rules the multiverse, then nothing is truly unique. Every story, every life, every choice may repeat over and over in endless variations. Our lives feel singular, yet in infinity they may be part of an uncountable chorus. It's unsettling, but also strangely comforting. For in infinity, nothing is ever truly lost. Every possibility has a place, somewhere, forever. Mathematical universes as pure reality. What if the universe is not made of matter, but of mathematics itself? Some scientists, like Max Tegmark, propose the mathematical universe theory. In this view, every consistent mathematical structure exists as a universe. Equations are not descriptions, they are reality itself. It's a radical thought. Our cosmos, with galaxies and atoms, may simply be one solution to a vast equation. But so too are countless other solutions, each unfolding as its own reality. The multiverse, then, is not a physical space but a mathematical landscape. In such a picture, parallel universes are not out there in space. They exist in the realm of math, timeless and eternal. Every possible structure, every possible rule written like geometry on an infinite canvas. It feels abstract, yet mathematics already shapes our world. From the orbit of planets to the growth of seashells, patterns of math reveal themselves in nature. If math explains everything we see, why not everything we cannot see? In this way, mathematics may be not just our tool, but the very essence of reality, a reminder that truth can exist beyond matter, in the purity of numbers alone. The idea that numbers themselves can be worlds. Numbers, so simple, so familiar, may hold more than we imagine. Consider the infinite decimals of pi, endless, never repeating. Hidden within them are every pattern, every sequence, every story you could ever imagine. Entire worlds could be encoded within the digits of one number. If numbers can hold infinity, could they themselves be universes? Every mathematical possibility, every structure existing as its own reality. A cosmos where geometry is not drawn but lived, where equations are not written but breathed. This is not far from how mathematicians already think. They speak of abstract spaces where points and lines exist, regardless of whether we see them. In their eyes, these spaces are as real as mountains and rivers. If so, then every number, every pattern, every equation may be a world in itself, not imagined, but existing fully in its own right. We live in one mathematical reality, but infinite others are waiting in the eternal library of numbers. It gives a strange comfort, for even if our world fades, the mathematics that describes it may never die. It will exist forever alongside countless other realities in the endless ocean of numbers, simulated universes born from computation. The rise of computers has given birth to a new possibility. What if universes can be simulated? If a powerful enough system could calculate every particle, every interaction, it could create a universe inside itself. To those living within, the simulation would feel as real as ours. It may sound like science fiction, but already we simulate small worlds. Entire galaxies are modeled in supercomputers, star clusters evolve in digital code, and even the weather of planets is recreated virtually. What happens when these simulations grow so detailed that they mirror reality itself? Some philosophers suggest we might already live inside such a simulation. If advanced civilizations exist, they could run countless universes, each as detailed as ours. Statistically, it might even be more likely that we are simulated than not. If true, then reality becomes a layered story. Our world simulated by another, which may itself be simulated, in an infinite chain of realities, each one unaware of the one above. The thought is unsettling, but it also opens the possibility that creation itself is not limited to physics. It may also belong to minds coding realities as easily as stories. Could we be living inside a vast simulation? The question has haunted thinkers for decades. If our universe can be simulated, how would we know if we are inside one? Physics may offer clues, strange glitches, digital-like limits to energy, pixelation of space at the smallest scales. Already, some scientists search for signs. Quantum mechanics itself feels suspiciously like code, probabilities collapsing when observed, as though the universe only renders what is needed, like graphics in a video game. Are we living in a reality that turns on when we look? Even the constants of physics, the speed of light, Planck's constant, feel like built-in limits, settings chosen by a programmer. They define what can and cannot be done, much like the rules of a simulation. If we are simulated, it raises question: who wrote the code? Why was this universe chosen? Is it an experiment, a story, a game, or something beyond our imagination? The idea may never be proven, but it reminds us that reality is not always what it seems. Whether simulation or not, the fact we can wonder about it is proof of consciousness, and consciousness is its own kind of miracle. Consciousness is a bridge between parallel worlds. Some thinkers wonder if the mind itself could reach across universes. Consciousness, so mysterious even in neuroscience, might not be confined to this single reality. Perhaps it brushes against others, catching glimpses of what lies beyond. Dreams, intuition, sudden insights, they sometimes feel as though they come from nowhere. Could they be echoes of consciousness, moving briefly into parallel worlds, carrying back fragments? Science has no proof, but the mystery of the mind remains one of the deepest puzzles. When physicists describe reality, they often focus on matter, energy, and laws. Yet consciousness remains unaccounted for. If it is more than chemistry in the brain, then maybe it exists in a wider space, free to touch more than one universe. This would explain why awareness feels larger than the body, why imagination can hold endless worlds, why thought itself sometimes feels infinite. Consciousness might not be trapped, it might be a traveler, and if so, then perhaps every dream, every flash of insight is a quiet step across the threshold of another universe, one we can never quite grasp but always feel near. Dreams as echoes from other universes. We spend nearly a third of our lives asleep, wandering through dreams. Strange landscapes, impossible events, people alive again who should be gone. Dreams defy the rules of our universe, yet feel vivid and real. What if dreams are not inventions of the mind, but windows, glimpses into parallel worlds where different choices were made, different events unfolded? In those universes, the stories we dream might be happening for real, and in our sleep we drift close enough to sense them. Some psychologists see dreams as fragments of memory and desire, but others quietly wonder if their surreal consistency points to something more. Entire narratives unfold in dreams as though they exist independently, as though we are tapping into them rather than creating them. Even déjà vu feels like a dream repeating itself, a moment that has already happened elsewhere. A faint memory of a life we never lived here, but perhaps lived in another branch of reality. If so, then sleep becomes not just rest, but travel. Each night we may be slipping sideways into other universes, waking with only shadows of those journeys still clinging to us. Déjà vu is a window into alternate timelines. Almost everyone has felt it, that strange shiver when a moment feels familiar, as if lived before. A street corner, a conversation, a face. Déjà vu lingers like a ghost, reminding us of something we cannot place. Science explains it as a quirk of memory, neurons firing twice. But some imagine it as something deeper. Perhaps déjà vu is a glimpse across parallel universes, a brief overlap between timelines. For an instant, your life here and another version of your life elsewhere align, and you feel the echo. The sensation is uncanny because it breaks the illusion of singularity. It whispers that your life is not one straight line, but part of a web of branching paths, all unfolding at once. In those instants, perhaps the veil thins. You stand in two places at once, living both, sensing both, before the moment slips away. And though fleeting, déjà vu leaves a mark, a reminder that reality may be layered, and sometimes those layers press close enough for us to feel their weight. Ghost particles crossing from universe to universe. Physics has long studied particles too strange for comfort. Neutrinos, for example, pass through matter almost untouched. Billions stream through your body each second, unnoticed. Some scientists wonder, could there be particles that slip not only through matter, but between universes? These ghost particles might be the messengers of the multiverse, rare, elusive, but carrying information from places we cannot reach? Every unexplained detection, every anomaly in particle physics tempts us with the thought that we are seeing shadows from other realms. If such particles exist, they could be the first proof that parallel universes are not just theory but reality. A physical fingerprint of something beyond. The very idea is thrilling, for it would mean universes are not perfectly sealed. They touch, they exchange, they bleed into one another through the smallest cracks. And maybe, somewhere in the silence of a laboratory, a detector has already caught the faint breath of another world passing by. Why neutrinos are called messengers of the multiverse. Neutrinos are among the strangest of particles. They have almost no mass, no charge, and travel close to the speed of light. Most pass through entire planets without a single collision. Because of this, physicists call them ghost particles. But neutrinos also carry information. Born in the hearts of stars, in the collapse of supernovae, in the early seconds of the Big Bang, they stream across the universe untouched. They arrive carrying the story of where they came from. Some theories suggest neutrinos might do more than that. Perhaps they interact with hidden dimensions, slipping between universes as easily as they slip through matter. If so, they could be the true messengers of the multiverse. Detectors buried deep underground in ice, in mountains, are already listening for their faint signals. Every flash of light they record may hold secrets older than galaxies, hints of realities beyond our own. If neutrinos are indeed messengers, then the universe is not silent at all. It is whispering constantly through streams of ghostly travelers passing from one cosmos to another in endless waves. Cosmic rays that hint at other dimensions. High above us, space is alive with invisible travelers, cosmic rays. Tiny particles launched at near-light speeds, crashing into our atmosphere with energies greater than any particle accelerator on Earth. But sometimes their behavior puzzles scientists, as if they don't belong entirely to this universe. Some theories suggest cosmic rays might come from other dimensions, piercing through barriers, slipping into our skies like messengers from elsewhere. Their strange energies could be the fingerprints of physics not found in our world. When detectors capture these rays, they often see anomalies, particles too powerful, directions too unusual, events that defy explanation. Could these be whispers from universes pressing against ours? If so, every spark in the upper atmosphere could be a signal. A quiet tap from a parallel cosmos reminding us we are not alone. And as we study them, cosmic rays may turn out to be not just noise, but the oldest letters in a cosmic correspondence. The multiverse hidden inside black hole singularities. At the center of a black hole lies a mystery. The singularity where space and time collapse into an unknown state. Here, the laws of physics as we know them break down completely. But some scientists believe these singularities might be more than endings. They could be beginnings. Perhaps each black hole is not a dead end, but a seed. A place where the collapse of matter ignites a new universe, hidden on the other side of the veil. Our cosmos, in turn, may have been born from such a singularity long ago. It's a breathtaking thought that every black hole in our sky may contain an entire universe inside it, each one carrying stars, galaxies, and perhaps life, expanding silently beyond our reach. From our perspective, a black hole swallows. From another perspective, it gives birth. Destruction and creation woven together, two faces of the same cosmic truth. And if this is true, then the night sky may not be filled with tombs, but with countless hidden wombs of creation. The strange horizon where information may escape. One of the greatest puzzles in physics is the information paradox. When matter falls into a black hole, does the information it carries vanish forever? If so, the laws of quantum mechanics are broken. But if not, then how does it escape? Stephen Hawking once argued that information might leak out slowly, encoded in faint radiation, now called Hawking radiation. If that's true, then black holes may not only trap, but also communicate, their horizons becoming thin curtains where secrets pass through. This idea leads to a startling possibility. What if the information released is not just data from our universe, but signals that connect to others? Black holes could become bridges not through matter, but through the hidden exchange of information. Some physicists even speculate that universes may overlap through these horizons, sharing whispers of their existence across the event boundary. If so, then every black hole is less a prison and more a portal of knowledge, an edge where realities may quietly touch. Physics experiments searching for hidden universes. The search for parallel universes isn't confined to imagination. It happens in laboratories every day. From underground detectors catching ghostly particles to accelerators smashing atoms, scientists are hunting for signs of dimensions beyond ours. The Large Hadron Collider has already revealed the Higgs boson, but some hope it may also uncover particles that hint at extra universes, subtle imbalances, tiny asymmetries, cracks in the rules of physics that suggest a larger stage. Other experiments place mirrors in sensitive chambers, hoping to catch particles vanishing into other dimensions, then reappearing. A kind of cosmic peekaboo, too faint for ordinary eyes but possible for precision machines. Even gravitational wave detectors are listening, hoping that a ripple too strange, too unusual, might reveal collisions not in our universe, but between universes. Gravitational waves that may reveal parallel worlds. When massive objects like black holes or neutron stars collide, they ripple space itself. Those ripples, gravitational waves, travel across the cosmos, stretching and squeezing everything in their path. We first detected them in 2015, confirming Einstein's century-old prediction. But some scientists wonder if certain ripples might carry more than collisions. Could they hint at events beyond our universe? If parallel worlds exist, their motions might leave fingerprints on these waves, faint distortions riding across the sea of space-time. Detectors like LIGO and Virgo are already listening, catching whispers from billions of light-years away. Most match expectations, but someday a signal too strange may arrive, a wave that doesn't fit our physics, a hint that something else is moving somewhere else. Imagine it, a faint tremor passing through Earth, not from our stars, but from universes brushing against ours. The thought is both eerie and awe-inspiring. In that moment, gravity itself may become our bridge, carrying news from worlds we cannot see but can feel ripple through us. Cosmic collisions as evidence of other universes. The night sky is filled with echoes of violence, galaxies colliding, black holes merging, stars tearing each other apart. Yet some scientists believe certain collisions may be more than accidents. They may be interactions between universes themselves. In some models, universes can brush or bump against each other like bubbles in foam. When they do, the collision might leave scars, strange patterns in cosmic background radiation, odd alignments of galaxies, or even unusual bursts of energy. A few anomalies already tease us. Cold spots in the microwave background, alignments that don't fit standard models. Perhaps these are cosmic bruises, the faint aftermath of universes colliding in the distant past. If so, then our universe carries memories, scars on its skin from encounters with neighbors we cannot see. Each mark telling a story of contact, of impact, of creation. It's a haunting possibility that our universe has been touched before and may be touched again. The silence of the cosmos as a multiverse clue. When we look outward, the universe is vast, billions of galaxies, countless stars. Yet we hear silence, no signals from other civilizations, no evidence of life beyond Earth. This paradox, so many chances yet no sound, is called the Fermi paradox. Some suggest the silence is itself a clue. Perhaps life is rarer than we think, or perhaps most universes are lifeless. If the multiverse exists, then ours may be one of the very few where life found a way. And that rarity explains the silence. Others wonder if civilizations rise and fall quickly, their voices too brief for us to catch, or if they exist, but in universes parallel to ours, forever unreachable. Silence, then, is not emptiness, it's a reminder, a whisper that maybe life is fragile, a rare flame flickering in a cold infinity. And yet within that silence, we exist. A small voice in the dark, proof that life can bloom even against the odds. Philosophers questioning if multiverse is real or imagined. The idea of parallel universes is not only for scientists. Philosophers, too, wrestle with it. They ask, if other universes exist but we can never touch or measure them, are they real? Or are they imagination dressed as science? For some, the multiverse is the natural conclusion of physics. For others, it's a dangerous dream, untestable and unfalsifiable. Where do we draw the line between bold theory and fantasy? Philosophers remind us that science is not only about answers, but about questions. Even if parallel universes remain forever beyond reach, the very act of thinking about them stretches our minds, and perhaps that is their value. To remind us that reality is larger than we imagine, that humility must walk alongside knowledge. Whether real or imagined, the multiverse keeps us wondering. And wonder, after all, is the root of both philosophy and science. Religious visions of infinite worlds beyond ours, long before physics, religion and spirituality dreamed of infinite worlds. In Hinduism, universes rise and fall in endless cycles. In Buddhism, countless realms unfold like reflections. In Christianity, some mystics spoke of many heavens. For the Greeks, infinite worlds drifted in the void. These visions may not have spoken of quantum mechanics or inflation, but they shared a common intuition that reality is too vast for one world alone, that creation spills over, multiplying endlessly. Even today, spiritual seekers see the multiverse as a way of understanding the divine. Each universe a verse in a cosmic poem, written by something greater than ourselves. For believers, parallel worlds are not cold physics. They are part of a story of meaning, a reminder that we are not at the center, but part of a vast and ongoing creation. Science and religion often differ, but here they meet quietly. Both gazing into the infinite, both sensing that our universe may only be one drop in a boundless sea. Ancient Hindu and Buddhist cycles of many universes. In Hindu thought, the universe is not a single event, but an endless cycle. Creation, preservation, and dissolution repeat endlessly, with new universes born as others fade. Each cycle is measured in cosmic time spans so vast that even galaxies seem young beside them. The Bhagavata Purana speaks of countless universes bubbling like foam in the ocean of eternity, each one held within the breath of Brahma, the cosmic creator. When Brahma exhales, universes arise. When he inhales, they dissolve. An endless rhythm of existence. Buddhism, too, describes realms upon realms, some visible, others unseen, planes of being shaped by karma, universes stacked like reflections in a hall of mirrors. To Buddhists, existence is not confined to one world, but spread across countless dimensions. These visions were not meant as science, but as insight into the nature of impermanence and infinity, yet they echo strikingly with modern ideas of multiverses, of cycles, and endless creation. It's humbling that thousands of years before telescopes, people already sensed the vastness of existence, already whispered that reality could not be contained in just one world. Greek thinkers and the plurality of worlds. The Greeks, too, wrestled with the size of reality. Democritus, the ancient atomist, imagined infinite worlds scattered through the void, some barren, some full of life, each formed by the chance assembly of atoms. To him, our world was not unique, it was one of many. Epicurus later wrote that the universe has no edge, and in that endlessness worlds beyond counting must exist, some like ours, others utterly different. To these philosophers, infinity naturally meant plurality. The cosmos too vast to allow just one earth, just one sun, just one story. Not all agreed. Aristotle insisted the universe was singular, perfect, and finite. His vision held sway for centuries, closing minds to the idea of many worlds. But the seeds planted by Democritus and Epicurus survived, quietly waiting, ready to return. When modern science revived the idea of multiple worlds, it wasn't entirely new. It was a return to an old intuition. The thought that infinity cannot help but create countless variations. And so the Greeks remind us that even in the earliest days of reason, humanity already looked outward and wondered if we were one among many. Modern cosmology reviving ancient intuitions. With the rise of modern cosmology, ancient whispers found new voices. Theories of inflation, quantum mechanics, and string theory brought back the old idea that many universes might exist side by side. But now the visions were dressed in equations, data, and physics. It's striking how often modern discoveries echo ancient myths. The cosmic foam of Hinduism, the infinite worlds of Democritus, the cycles of Buddhism, all resonate with multiverse models born from modern science. As if intuition long ago glimpsed what equations confirm today. This doesn't mean ancient visions and modern physics are the same. One spoke in poetry, the other in mathematics. Yet both point toward the same horizon, that reality is too vast, too layered, too infinite for one world alone. And perhaps that is the beauty of the multiverse idea. It bridges myth and science, imagination and data, spirituality and reason, reminding us that the hunger to understand existence is universal across time and culture. In this way, cosmology does not erase ancient thought. It extends it, carrying forward humanity's oldest intuition, that creation is endless. Why multiverse ideas inspire both awe and doubt. Few ideas in science spark as much wonder or as much skepticism as the multiverse. On one hand, it offers answers to deep puzzles, fine-tuning, quantum strangeness, cosmic anomalies. On the other, it feels almost too vast, too unprovable, like reaching into dreams. For some, the thought that countless universes exist fills them with awe. The sense that reality is bigger than we can ever grasp, that our existence is part of something infinite, eternal. For others, it feels like a cheat, a theory so wide it explains everything and nothing. Scientists argue fiercely over it. Some embrace it, pointing to mathematics and models that nearly demand it. Others reject it, insisting that science must deal only with what can be tested, not imagined. The multiverse walks a fine line between possibility and speculation, and yet whether accepted or doubted, the idea continues to inspire. Artists, philosophers, dreamers, scientists, all drawn to the thought of countless worlds, endless stories, infinite skies. Perhaps that is its true power, not certainty but wonder, not answers but the courage to keep asking questions. the emotional weight of living in one timeline. If infinite universes exist, then every possibility plays out somewhere. But here, in this universe, we live only one life. One timeline, one story unfolding with every choice we make. That thought can feel heavy. There's a bittersweetness in knowing that other versions of us may exist, living different lives, making different choices, while we remain bound to this one path. We wonder, what if I had turned left instead of right, chosen differently, spoken differently, loved differently? The multiverse offers comfort. Those lives exist somewhere, real and unfolding. Yet it also sharpens the preciousness of this one. For this is the life we know, the moments we can touch, the choices that shape our days. Instead of despair, this thought can bring gratitude. Out of infinite branches we are here, awake in this timeline, watching these stars, breathing this air. That alone is miraculous. And so, even as infinite worlds stretch beyond us, this one remains our home. A single path in an endless forest, no less beautiful because it is only one. Every experiment is a quiet act of curiosity. A reminder that the greatest discoveries may not be far away, but hidden in the smallest anomalies, waiting for us to notice. The Large Hadron Collider and Extra Dimensions. The Large Hadron Collider, buried beneath the border of France and Switzerland, is the most powerful machine humans have ever built. It smashes particles together at nearly the speed of light, recreating conditions just moments after the Big Bang. While its headline discoveries, like the Higgs boson, have reshaped physics, some scientists hope for something even bigger, evidence of extra dimensions. If particles vanish unexpectedly or new ones appear, it could mean our universe is only a slice of a greater whole. The collider's collisions may shake loose particles that don't belong here, particles slipping into another dimension or falling from one into ours. If observed, this would be the first hard evidence of a multiverse. So far, nothing definitive has appeared, but every run of the collider is another chance to see a crack in the fabric, another chance to glimpse what lies beyond the curtain of our universe. And just the fact that such possibilities are within reach is itself remarkable. Humanity, on a small planet around an ordinary star, daring to probe the possibility of infinite worlds.